All right. So yesterday we did the translation. So some of you have shared your work and you have done the rotation also, and it was good only. Uh, I think one student had some issue with it, but others were able to do it. So that's all good. So let's do the rotation. So yesterday I said that you can like rotate it 180 degrees and that will work out. Now, like if you want, because like some of you have slightly increased the height more than this. So if the height is more, you can then increase the rotation also. Okay. So Saidal, please text me regarding this. Okay. I don't know why it's crashing. It shouldn't crash if you just change the autosave settings. Okay. Uh, all right. Let's continue. So yeah, as I said, you can increase the rotation amount. All right. So yesterday I just did around 180-degree rotation. So you can increase this rotation. So you can do around 360 as well. So like here it's around 360 now. So you can see this is a good rotation. Okay. All right. And then after that, we can continue with that amount of rotation. Now you can see I'm trying to land the ball upright. There's a reason behind this because if you want, you can then very easily add squash and stretch. Whereas if you land the ball like this, then you cannot add squash and stretch. And the way it is bouncing, initially there will be a little bit of squash and stretch, and then since the height has decreased so much, there won't be so much of squash and stretch later on. So, like initially, if you want to add a little bit of squash and stretch, then definitely make sure to land it straight. Okay. Okay, people, like, what are you discussing? Yes, exactly what Sudhakar said. The demo class is for 12 days long. And if you like it and if you wish to continue, you can take the course. And if you don't want to, you don't have to take the course. It's completely your choice. Regardless of that, you will learn quite a lot during the demo. Okay. So, yeah, I will just ignore the messages now because I need to explain. Let me undo this. Okay, so the first rotation I have done, I've increased it around 360 degrees. You can see 358. So almost 360 degree. You can like make it completely straight as well. The reason why I'm landing it upright like this, so that I can easily squash and stretch. Whereas if you keep it rotated, what will happen? If you land it like this, then the squash and stretch won't come out easily. See, it will be like this, then you'll have to change the angle. So it will be very problematic. So if you're planning to add a little bit of squash and stretch, just make sure to land it straight initially when the rotation is high, because the height is high. And as soon as the height decreases, the rotation decreases, and therefore squash and stretch will also obviously decrease. Okay. So then later on, we won't be adding it. So just for the initial frames, if you want, you can like, if you want to add squash and stretch, just land it like this. Okay. All right. Let's continue. And now at the top point, again, I will rotate it quite a lot. And then at landing again, I will rotate it like this. So you can see nice amount of rotation. So I have kept the similar amount of rotation in the second height as well. Okay. So yeah, as you can see, it lands like this. And then I'll continue. This time I will reduce the rotation because the height has very much reduced, right? So now I'm like doing around 180-degree rotation only, or maybe 90 degrees, like it depends. We don't want to increase it way too much. After this, like I will just continue again with this much rotation, and then I will decrease. Now at this point, you can continue decreasing the rotation because the squash and stretch won't be present as much. So you can continue keeping it decreased only. Okay. So you can see we get something like this. All right. And now, like if you want to convert this into squash and stretch, we can very easily do that. Let me show you. So I have this controller. We know that right before that, we don't want it to, like we want it to be round only. So we will key it over here, key it at 15 as well. This is the impact frame. So this is where I will squash it. So now we have added a squash. You can see I'm not adding too much. I'm adding a little amount only. All right, now for the stretch part, I will use the lower controller. So again, at the point of impact, I don't want any changes. So I'm keying it there. Here, obviously, we want to stretch it out, but before we stretch it out, I will go ahead and lock it at 12th frame so that the shape doesn't change. I will do the same thing here. So now you can see I've added like three keys. So now in between where we have the empty space, that's where we will be stretching it. Yes, it doesn't squash and stretch that much. That doesn't mean that you cannot add it. You can always go ahead and change the ball, right? I'm just saying that if you want to experiment with this, you can do it like this. You can just change the ball and now it's a different type of ball. It's not a big deal. Okay. You can just change it and have a different outcome. So yeah. So here, if I want to stretch it out, you can see I changed something. Usually, whenever we are working with controllers, always been doing it in the world axis. Okay, we get into these axis settings by pressing W and left mouse button. So by default, we are in working in the world axis, which always stays upright like this. Look at the manipulator. Look at this little one. It is exactly the same, right? But when you go to the object mode, you will see it will follow the rotation amount. So this is very helpful because then you can just align it like this. Whereas if you were working in the world axis, it will go straight down, right? So that's not ideal. So that's why we do it in the object mode so that we can stretch it out. Okay. Yes, Sudhakar, exactly. You understand. Okay. The shortcut is press W and left mouse button. Okay. W and like if you want to change for translation, if you want to change for, let's say, rotation, like here, rotation is not possible. Let me select this one. So you can see if I'm in the world axis, it will remain straight like this. If you want it to be in the object mode, you can press E, left mouse button and go to object. And when we're in translation, normally we are in the world axis. So if you want to change it, press W, W for translation, E for rotation, and R for scaling. So that's something that you'll have to press according to the manipulator that you want to change. So since we're changing translation, I'm pressing W, left mouse button, and I'll just go to the object mode. Okay. And I will stretch it out. So you can see it's stretching out here midair, and then it is flattened. And then here we stretch it out again. So you can see we got the squash and stretch. See how nice it looks? It's looking a little bit more exaggerated this way. You see these 12 animation principles, the reason why we have them is because not everyone is capable of creating wonderful animations just like that. It's not like a like it's not something you're always born with. Okay. So that's why we have these 12 principles. So whatever you're animating, you can apply them at each point. You can always check, like let's say you did one simple motion where your character is looking from one side to the other side, right? So when that happens, you can apply all the principles there, and that way, like even if you don't understand how to make it good, if you follow the principles, naturally your work will look better. All right. And of course, applying them is difficult when we don't understand how to apply them. So of course, throughout the classes, I will always be explaining. So we've already covered uh, squash and stretch. And apart from that, we have also covered something known as an arc. Like you can see the way the ball moves, it falls down and like it goes in a circular pattern, right? At the top. It's not going like a straight zigzag pattern because that's not how natural movements happen. Natural movements always happen in a curvy type of flow, which are known as arcs. Okay. So, yeah. So arcs are something that will always happen, doesn't matter what you're moving. Like even when we move, when we're moving our head, we're always like moving it in a round motion, not like a robot, right? So that's why, again, this principle also helps to create animations uh, and make them look more smoother and more believable. If you have a zigzag pattern, it will look unnatural and robotic. Okay. Raj, no, you don't have to unlock hidden attributes. I'm sure you're talking about the channels. If a rig is made a certain way, don't try to unlock it. Okay, because if you do that, it will ruin things for you. So just let it be and do it according to what is given to you. The reason they lock it is because if you use those controllers, it will mess the rig up. So just use it as it is. All right, let's continue. So you can see, like previously, when I added the squash here, I used the top controller. Now the in the next impact frame, it's also the same. Sometimes you will land like this, where you will have a different controller at the top. So you just have to work accordingly. Okay. All right. So same thing will happen here. Now, right before I squash it, it's easier for me to key a frame before that and a frame after that. And then I can just come at 38 and I can squash it, right? And then for the stretch, again, I know that at the point of impact, I don't want the slow controller to move. So I key it. I key one frame before the main stretch point and one frame after the main stretch point. And now we are just going to stretch these out. And now you can see this is how it looks. Now make sure to keep reducing the amount of squash and stretch. Like here I've done it this much. So at the next point, I will reduce it, okay, because the height is reducing, right? So here it's quite a lot. Here I decrease it. We'll do the same thing for the stretch as well, okay? Because the height is reducing, it is going to affect each and everything. Now, for the second one, also we'll do it the same way. Let's lock the frames and squash it. So let's compare. So we can see I have actually increased it more. So let's decrease it. So you can see it's even more decreased compared to this one, right? Uh, for this thing, if you use a graph editor, it will be difficult because you have to lock it literally frame by frame, right? So there's no point in using a graph editor in this case. We have to use the key method, okay? You can see like how closely we need to control the movement. So graph editor is something that we use when we control the movement throughout a key span, right? Let's say if you wanted to control the movement from 40 to 55, then you would use the graph editor. In this case, we're very closely controlling it, so it's better to use the key method and not the graph editor. All right, so we've added the squash. Let's go on to the stretch. So at the point of impact, I'm keying it. We know that here we have to stretch, but right before that, I'll key it. And right after that, I will key it. And then I will stretch it out a little bit over here. So you can see very much reduced it. And now after that, if you want, again, you can go ahead and add another squash and stretch because we're landing upright only. So I think we can afford one more squash and stretch. Let's do that. So it lands like this. I will very subtly bring it down. So you can see it looks like it is almost round only. So at the next time, even if it doesn't, if even if it isn't, impacting upright like this, it will still work out for us. Okay. Uh, Let me select the controller. I will delete this. First, we must key the before and after, and then here we will squash it. Very little amount of squash, and then I'll take the controller, key the impact, key before and after, and then here very slightly, I'm going to stretch it. And now you can see even if the ball is not squashing and stretching anymore, it works out. See? So that this is how we have decreased the squash and stretch according to the movement. So if you're deciding to add squash and stretch, then definitely you can change the football to a normal ball. Okay? Like a simple ball. And if you know how to render things with the proper light, you can do that also. You can just select the object. You can see it is not selectable from here. So if you want to change the material, you will go to the outliner. You'll open the group, this group as well. You can see one is for mesh, one is for control. So open the mesh group, open the ball types, and you have the simple ball here. Once you have grabbed the object, go to the attribute editor, and we have these little icons here. You can right click on it and you will get the shader. Click on that, we have the shader, and from here you can change it. Like if you're using Arnold for rendering, you can choose any AI ones, or you can choose V-Ray if you have V-Ray. I personally use V-Ray. Okay, so just like that, you can change it. I will be rendering the next exercise, which will be the ball characterization. Okay, so we will be rendering that. So yeah, you can change the material like that. All right. Is this clear to everyone, the rotation and the squash and stretch thing? Please tell me if there's any confusion. It's all clear? Okay. All right. Cool. So I'll save this file and I'll just open a new file. So now we will start with the ball characterization. So first of all, we will be discussing certain aspects. There are different types of poses that we have that help us plan out uh, basically any animation. Along with that, we will be doing a storyboard also. So what is a storyboard? Basically, whenever you're working, like when you start working in a studio, you will see that mostly when they plan out what animation needs to be done, they always create a small storyboard. So storyboard is very similar to how you see comic strips. Like if you have read any comic, and even if you haven't read any comic, I'm sure everyone must have seen images of a comic. So you see little boxes where different images are drawn, right? So if you read what's happening and you see all those images, story becomes very clear, right? Even though it's not a full animation, those are just images of different scenarios, like whatever is happening in that particular moment. So just like that, we have something known as a storyboard where we create different sketches, rough sketches, to define what will happen in a scene. This gives us an idea and helps us to plan out the shot. Okay, so that's exactly what we'll be doing. Storyboarding is usually done, mostly it is done for things like you can see the type of character we'll be using. We'll basically be using a ball and we will create it into a cartoon character. So any character which is like not very human based, we tend to use storyboards. And even for human animation also storyboarding is done, but not every studio has a storyboarding artist. So what they do is they instead just shoot the reference and then they create an animatic where basically they take the rig and they do rough animation. So those are different types of methods that are used in the industry. No, you don't need any good drawing skills. Okay. You just need rough and like rough poses. Just it should be clear enough to understand. You don't have to be super good in sketching. Okay. So yeah, let's start. So let me explain the story. Basically, let me open the file first so I can show you what exactly the setup will be, and then we'll discuss. Okay. So we won't be animating anything. We will just be uh, planning out the story. Okay. So this is our scene. We have a basketball hoop and we will be like animating it like a basketball. So basically, this ball has a goal. It needs to go inside the hoop and it has to do it on its own. See, what happens in reality when you play basketball, you dribble it, you run through the court, and then you bounce and like basically throw the ball. It hits that red line over here and it drops inside the hoop, right? So you're controlling the ball. In this case, what will happen? This ball will be a character. So just imagine what goal of a basketball would be like if it was a cartoon character. So its only goal that I have decided will be to shoot through the loop, this hoop. Okay. So basically, this ball is looking at this basketball hoop as an enemy or as a goal. Okay. So this is how we will be planning out the story. Like the ball will enter the scene. It will come from over here. Okay. Like I will just roughly animate to show you, and then we will get down to storyboarding. So it will become even clearer for everyone. Okay. So like I have the controller selected. So I'll put a key here. So we make the ball enter the scene. Okay. It enters the scene and it will not just suddenly stop here. See, what happens in reality is whenever like you lift up your hand or like any simple motion that you're trying to do, you don't just start doing it from one point to the other point and you just suddenly stop. That is something that doesn't happen. What always happens is a little back and forth. Like you can see, this ball reaches its final destination. It will not just suddenly stop because it has gained energy, it has gained speed, right? It cannot just suddenly stop like a robot. It needs to have a natural momentum. So it will go back and forth. So basically, it will go front and back and then it will come to a full stop. Okay. This front and back motion is known as dampening. Okay. This is something that you will always be applying in whatever movement you're doing. Okay. The dampening motion, that means nothing ever stops at one point. It will go backward, forward, or it can go forward and backward depending on what the movement is. So in this scenario, the ball was already moving forward. So what it does is it goes back, it goes forward, and you can again make it go slightly back. You can see the amount of movement I have like really reduced it. See the first one, when it goes back, it moves quite a lot. Then when it moves forward, it moves less. And when it moves backward again, it moves even lesser. So dampening, like this is something that we study in physics also. Okay, like if you see the graph editor for this movement, which is translate X, so you can see we have like if I increase this, like I have really moved it quite less. So like if I increase it, just see the shape that forms. Okay, I'm just trying to show you the shape. See what's happening? The height of the curves here are decreasing, right? Up and down, and it is slowly decreasing. Let me show you the same thing in physics that we see. See over here, this is the dampening movement. See, it goes up and down, and finally stops. Okay, this is how it works. So, whatever movement you're doing, you don't suddenly stop any movement. Doesn't matter whether you're working with a human character, with a cartoon character, with a quadruped, which is an animal, because that's what happens in reality. Just try to do any movement and record yourself in slow motion. You will see. Okay. Just try moving your hand. You will see that when you start moving it, first of all, it doesn't just start from one single point. It goes slightly backward and then it starts to move forward. And then when you make it come to a stop, it again goes backward and forward. Yes, open range, inertia. Okay. It happens because there is mass, there is energy into it. It cannot just come to a sudden stop. So the reason why I'm showing this is because this is how the pattern looks in a curve. Okay, when you're moving it back and forth, this is the type of shape that comes through in a curve. Okay, you can also call it as oscillation. Okay, backward and forward movement. So you don't have to worry about the physics behind it, but just experiment on your own. You can please just record yourself in slow motion, do any movement, and you will see, like, just move your hand from point A to point B, and you will see that it will not just suddenly stop unless you really control it by making your hand really stiff. Only then you can make it come to a stop. Even then, your hand will still move a little bit. It's not possible to just completely stop because obviously we're not robots, right? We don't move in a calculated way. Okay, nobody is controlling us, we're moving it on our own. So yeah, that calculation part is not happening. That's why it cannot just suddenly stop. Yes, Sudhakar, it is also known as an overshoot. Okay, don't worry about these fancy names right now. Just understand why this happens. All right, so yeah, let me undo the movement that I have done. Okay, so you can see the slight back and forth movement. And then what will happen? Like, basically we will be animating the camera as well. First we will roughly do an animation here, and then we'll start moving it with the camera. So first the camera angle might be like this as the ball enters the scene. Next camera angle would be like this, where this like, see, you need to show a goal, right? If there are two characters, because here basically there are two characters, even though this basketball hoop is not going to move, still it is a character. Like, because our main character, the basketball character, will be interacting with it. So this basketball hoop is also the second character, so we need to show what the goal is. So we will show a movement here, and then we'll come back to the ball and we'll show that this ball actually looks up towards this basketball hoop, because obviously you can see the height difference, right? If we consider them as two simple characters, you can see this ball is, like, obviously having such a less height, and this basketball hoop is having such a big height. So if you want to show that this character is looking at its goal, you will then be rotating it upwards like this. So it will look like that this basketball is actually looking at its goal. Okay. And then once we do that, we will then move it forward again, rotate it, and we will do up and down. Like, basically, we will be making the ball dribble on its own. Okay. Dribbling happens when you use your hand and you, like, basically bounce the ball. But here, since there is no one moving the ball will actually dribble on its own. So we will be doing a couple of things to make that happen, because you cannot just suddenly start making the ball move. We need to show something known as anticipation. So anticipation is another principle of animation. The, like, it is one of the 12 principles of animation. Whenever we watch any animation, we always see the, like, the preparation behind the action. Okay, like, it will not just start happening from a certain point. You need to show that the character is actually preparing for it. Like, when we start running, like, if you're deciding that you need to run, you pull your body backwards, you get into a pose, and then you start running, right? So that part is known as anticipation. Right now, I'm just talking about these concepts. I will be going through them again when we will be animating them. So you will, like, you will become, like, that thing will become more clear into your minds. Okay. So anticipation is something which is very, very important. Yes, it can be a moment before a hard punch. It can be anything. Doesn't matter which action is happening. You could just be making the character look from one side to the other side. Even there, you will have to add anticipation. Why? Because audience who is watching the animation needs to stay connected to the character, right? If the character is just randomly doing things, then the audience watching that animation cannot understand, because everything is just happening in one flow. So you need to show the connection between, like, the thought process between the action that is about to happen. Okay? Because see, whenever we do any movement, we think of it, our body acts it out, and then we actually do it. Okay? Like, let's say if you're about to say no or you're about to say yes, you instinctively start to move your head, nod your head to agree with them, to disagree with them. These small things happen in reality, we don't notice them. But this is how humans move. This is why this is a principle of animation, because this is something which happens in reality. See, all these principles are very much ground to reality, but they are more exaggerated versions of it. Because if we don't exaggerate, then what happens? The animations that we create don't look attractive. Okay. And it mostly happens because, see, whenever we're doing cartoon types of animation, we already have a disconnection that this cartoon is obviously something which is different from a human, right? So if that cartoon character moves and works exactly like a realistic human, then it becomes very boring because you're already disconnected from it because it looks like a cartoon. And on top of that, you have a boring, simple human movement on it. So it doesn't look eye-catching, it doesn't look attractive. Whereas if you're trying to do realistic human animation, like the ones you see uh, with Thor, sorry, not Thor, I said Thor accidentally. I meant Thanos. Thanos is a CG character, right? From Avengers. It's not a real character. It's fully CG. Same thing is for Hulk. They move very realistically, right? So if they start moving like a cartoon character, again you will get disconnected from there. Same thing happens with characters from Avatar, like that movie. You see all those characters, if like they're supposed to move in a very human, realistic way. If they start moving in a exaggerated way, you will not like it. So the movements we add into animations very much depend on how our characters look. Okay. So yeah, uh, yeah, so we have discussed just few principles, and obviously throughout this animation we will basically be covering uh, a majority of them. Okay. So let me show you. So I've created these little boxes where we will be sketching out what will happen in our story. Okay. So I'm using a brush, and basically these storyboards will help me create my final camera angles. So consider them as comic book strip boxes, and we will be sketching inside of them. So I will keep, like in the first shot, I will keep the camera tilted. Okay, I want there to be a slight tilt. And this is our ball. Okay, it enters the scene, rotates, and then stops. Okay, and then uh, after this, we want the basketball hoop to be visible. Okay, so in this scene, I will show the basketball hoop. Okay, so the camera will move from right to left, or it could also move from left to right. This is how the movement will be. Okay. Now the next shot again will be of the basketball. So this time I will keep the camera straight. So the ball will look straight to the camera. And here the camera, I will make the camera move from left to right. Okay. So basically, like you will remember seeing things like this in many cartoons, many movies, and even in games. When two opponents are there, cameras move in opposite directions like these. So we will be adding that. That's why I created these little arrows so that I can remember adding them. Okay. So these are three different angles of cameras that I will be using. Okay. So the ball here is determined. I will I will create a little arrow like this to show that the ball will be looking up towards the basketball hoop. Okay. Now in the next shot will be a broad shot where both the characters will be visible. So we have the basketball hoop here and we have our ball here. Okay. So the ball will actually move forward and reach a little closer to the basketball hoop. And then after that, what we'll do, we will make it jump up and down. Okay, so let's do that in the next scene over here, like just to show you clearly. So now this is our ball. It will start jumping. It will jump to a small height. Then obviously it will fall down, right? Then I will make it jump higher again. This time it will be a higher jump. It will come back down. So two jumps will happen, very similar to dribbling. Okay. So now in the next shot, what will happen? I mean, basically these are same shots only. I'm just showing you what will happen throughout the scene. Now, basically this ball is jumping to gain momentum. The ball doesn't have enough energy to just jump like this towards the hoop. Okay. So what it does by jumping up and down, it gains energy. Okay. It has now gained enough energy after doing two bounces. So after it reaches the ground in this jump, okay, it will now shoot forward and hit the board. And then it will drop to the hoop. Now here our camera angle will change. Now this time I will keep the camera close to the basketball hoop. So what will happen here? The ball will actually drop on this hoop and I will make it rotate around, do a circle on the hoop. Okay. And then it will just fall down. It will do a circle, it will fall down, and the next shot will be a close up of the ground. So we have the hoop here. It's like the full hoop is not visible, just halfway it is visible. So the ball comes down here on the ground. Okay. And in the next shot, what will happen? Like the ball is over here, right? Now from this point, it will bounce forward and exit the scene. So these are basically the things that I will be doing. Okay. 1 second. Let me just save this. Okay, it is saved. So this is a uh, very rough storyboard that we are creating. Okay, so yeah. Is this clear? Like, did you understand the process behind this? Okay, great. What do you mean by adding air? Chandrapal, no, that is 2D sketching. They do it like they are drawing over it. So this is 3D. So I cannot just do that directly. There are ways to do it, but that is not the part of animation here. Okay. That is not something that we can do. All right. Exactly. Exactly what they've said. All right. So now that we have discussed what we'll be doing, let's end the class till here. And we'll keep the class till here and we'll continue tomorrow. We'll start with the animation tomorrow. We'll be discussing names of certain poses. So there's a full theory behind it. So we will be talking about them and we will be animating them. Okay. All right. Chandrapal, are you not able to understand what everyone is saying? What enjoyment will you get if I add it? I mean, that's a post-production thing. Why are you so obsessed with it? You just go watch anime if you want to see that. Okay? Don't obsess over it, please. That is not the part of animation. You can get satisfaction just by watching anime, okay? Or learn post-production. Learn how to edit videos so that once you complete the animation, you can add it on your own. That is not a part of the course, okay? We're not doing those things. I don't know why you're so obsessed with it. So anyway, uh, no, you can do that, but it's not a part of animation. There are different departments for different things. Okay. We can also do it in 3D, but we'll have to do all types of sculpting to make that happen. So we are not doing that here. Yes, he's watching too much anime. Watch less anime, please. so that you can have realistic expectations. Everything which happens in anime cannot be just created, right? They are sketching it so they can make anything happen. All right. Uh, all right. S- It's looking boring. So we haven't even animated it yet, Chandar. How can you say it's looking boring? We haven't even animated it. You please go watch anime only. You want all those fancy things, then you can please go watch anime and just stay in that. I mean, we haven't even animated it yet. We are just discussing, and you're saying it's looking boring. Anyway, whatever. Uh, all right. Yes, he needs to stop. He's not stopping. All right, guys. Let's keep it till here. I'm getting a call. I had ordered food, so yeah, I need to have dinner. Prithvish, you can text me, okay? Whatever you want to ask, I will reply. All right, guys. Bye bye. Good night. Let's continue tomorrow. Thank you, Sudhakar. Good night, everyone, guys. Bye.